Hello everyone. Today our group would like to talk about application of determinant for our Math 263 class, which is linear algebra. And our group have Hasno, Mika, Aiman, and myself, Habil. So we have 4 group members in our group. So for the list of content, number 1 we have introduction. Number 2 we have purpose of study. 3 we have methodology. And for the number 4 we have application and function. 5 we have conclusion, and lastly we have reference. And for the introduction of this slide, which is a meaning of determinant. So I will explain a meaning of determinant. A determinant is a scalar value associated with a square matrix. For a 2 times 2 matrix, A, B, C, D. The determinant is AD minus BC. In general, for an n times n matrix, it is calculated using a sum of products involving permutations of matrix elements. The determinants provides essential insights into matrix properties. And for the purpose of study, the first one is to solve linear equation in Cramer's rule. And the second one is to find the function of Cramer's rule.
Okay, for example, so here is the example for the Cramer's question. So when we get this question, first step we need to find the coefficient matrix, which is matrix A and matrix B. How do we get matrix A and matrix B? Okay, basically matrix A we can find before the equal sign, and matrix B we can find after the equal sign. So for this question, the matrix A is 2, 3, negative 1, 4, negative 1, 2, 1, 2, negative 3, and matrix B is 10, 5, and negative 3. Okay, now cut. Okay, after we find the coefficient matrix, now we need to find the determinant of matrix A. How do we find the determinant? We can use any method such as cofactor expansion and others. So when we find the determinant for this question, we can get 31. After we get the determinant of matrix A, then we have to find the matrix of AX. How do we find the matrix AX? We have to replace matrix B into the first column in the matrix A, and then we get the new matrix, which is matrix AX. So for this question, the matrix AX is 10, 3, negative 1, 5, negative 1, 2, negative 3, 2, negative 3. So after we calculate the determinant of this matrix, we can get the value of 10. After that, how do we find the value of x? We just need to divide the determinant of matrix AX and the matrix A. So for this question, the value of x is 10 over 31. So after this, we have to find the value of y and z. Okay, so how do we find that? The value of y, we just need to repeat the same step, but when we want to change the matrix B into the column, for y we change it into the second column, and for z we change it to the third column. And then we can find the determinant of the new matrix, which is AY and AZ, and then we can get the value of y and z, and that's all.
Grammar rules and determinant has many functions in real world, but I will talk only two of it, which is precision of data and ill-conditioned system. So for the precision of data, real-world data often comes with limited precision, and calculation based on such data can be sensitive to rounding zero. If possible, work with data in its raw, high-precision form to minimize the impact of rounding errors. So basically, by using grammar rules and determinant, you need to work while the data in its raw form, so that you can eliminate or minimize the error that occurs in the data. Ill-conditioned system. Real-world problem may result in ill-conditioned system where slight changes in the data can lead to significant changes in the solution. This is a common issue in numerical linear algebra. Kramer rules is one of the simplified ways to solve linear equation in smaller system other than Gaussian elimination method. But in a larger system, Gaussian method are more reliable because it is more stable than Kramer rules. Basically, undeniably, Kramer rules is easier to use rather than other method. But in a larger scale, Kramer rules are not less stable, which can lead to error in data.
So it looks like we have come to the conclusion or application determinant. The conclusion for our presentation. One potential real life application could be in educational settings. What does that mean? Where the instructor or a teacher or a lecturer use grammar rules to teach their student the concept of solving a system of equation by using grammar rules. They teach their student using grammar rules to solve an equation, and it serves as valuable theoretical exercise to understand the role of determinant in linear algebra. Thus, in practical application, engineer, scientists, and of course we cannot forget mathematician often prefer numerical method like Gaussian elimination, LU decomposition, or matrix inversion for solving system of linear equation due to their computational efficiency and robustness against run-off errors. You guys must wonder, why do we need to learn about application of determinant? What do we use it in real life? Yes, we will use it in real life. Well, these methods are better suited for real-world problems with larger datasets and complex systems. So there you go. We use it in our real life, in our daily lives. But it's mostly for larger dataset or database and complex system. So yeah, that's about application of Bitcoin for the conclusion. And for the next one, so for the last one is just our reference for this presentation. We use Wikipedia and other things for our presentation about our cameras and application of determinant and everything. You guys can copy the link to check the our reference for this presentation.